Hello everyone and welcome back to our video number 13 of UPSC Civil Service Means Previous Year Question Solution. And today we will solve two questions. One is from strength of material, the principal stresses and maximum shear stress, and one is from welding. Okay, so without wasting time, let's start. So here in first question, I'm not going to read whole the data because we you have already the data. So the magnitude of stresses, tensile stresses, that is sigma x is given 120 megapascal tensile, sigma y is given 60 megapascal tensile, and tau shear stress 80 megapascal is given. Okay, so we have to find out is magnitude and direction of principal stresses and magnitude and direction of maximum shear stresses. And what is the normal and shearing stress plane inclined to the 30-degree to the direction of 120 meganewton per meter square. That means with respect to positive x-axis. So first of all, I am going to define the axis. This is x-axis and this is y-axis. Okay, so with respect to 30-degree, whatever the normal and shear stress will be there, we have to find in the last. But before we start, this is the first thing that we have to find, that is maximum principal stress and minimum principal shear stress. Sigma x, sigma y, tau xy, all the value we have, and this is the formula for this. I hope you know this formula because in the strength of material as well as in generally our all the production topics, they all are formula based. If you know the formula, then you can answer. So put the value over here, sigma x, sigma y, 120, 60 and 80. So you will get maximum principal stress as a 90 plus 85.44. So that means 175.44 megapascal. Now the similar thing, put all the value, but here there is a minus sign. So 90 minus 85.44, that will be 4.56 megapascal. 4.56 megapascal, that is minimum principal stress and maximum principal stress. Now whenever we have to find the maximum shear stress, so this term, let me tell, this term, the square root term, that itself is a maximum shear stress. Okay, so its value that we have recently find 85.44. So 85.44 megapascal, it's a maximum shear stress value. Now we have to find the location. That means this is this formula, tan 2 theta p. Theta p is angle of inclination of principal plane with respect to positive x-axis. 2 times tau xy divided by sigma x minus sigma y. Tau xy, put the value 80, sigma x 120, sigma y 60. So whenever you will solve, so we'll get two value, theta value, because in two quadrant 10 value is positive. So theta value, when you solve this in calculator, so you will get 34.72 and 124.72, and see the difference between them is 90-degree. Always the angle between two principal plane is 90-degree. And on Mohr circle, the similar thing is 180-degree, because on Mohr circle the angles are denoted by 2 theta. Okay, now the principal location of principal stresses, sorry, maximum shear stress, that means 10 2 theta s is equal to minus sigma x minus sigma y divided by, like this, or you can say that 10 2 theta p, the equation that we know, 10 2 theta p multiply by 10 2 theta s. That means theta s is what, the angle of maximum shear stress with respect to horizontal. It is equal to minus 1. Multiplication here is there, so just put the value over here. So you will get the 2 theta s value, that is theta s value is minus 10.27 degrees Celsius. Sorry, not Celsius, sorry, it's my mistake. Because after long session of thermodynamics, you will get to used to degree Celsius, but here minus 10.27 degree and 79.73 degree. Okay, and what this minus, that means if you draw on the Mohr circle, so this minus 10 will be like this on the negative side in the fourth quadrant, the value of maximum principal shear plane, and other one is 90-degree apart. Okay, so these are the two value of stresses. Okay, sorry, the value of angle of principal planes of shear plane. And note down that the angle between these two is 45 degree. Again, these two. So this should be matched, otherwise your answer is wrong. Now at 30 degree, this is the equation of normal stress, sigma n, sometimes we are writing, and tau. Okay, so this is the normal stress, sigma x, sigma y, 120, 60, and cos 2 theta. Here theta value is 30 degree, 2 theta will be 60 degree. So put all the value. So you will get normal stress at 30 degree, that is equal to 174.28 megapascal, and shear stress is equal to 14.02 megapascal. Just use this equation and put the value sigma x, sigma y. Theta is equal to 30 degree, sigma x, sigma y is 120 and 60. Again I'm telling you. So this is the answer. Please check with your answer when you solve this. And the last question of today is welding, that is voltage length characteristic and DC current. So voltage and arc length current relation is given by 22 plus 40L. Okay, and length of arc is in centimeter. The power source, it is a straight line characteristic. Power source is straight line characteristic is there. And open circuit voltage OCV, I will write open circuit voltage at OCV 80 volt, and short circuit current SSC, that is 1000 ampere. We have to determine the optimum arc length and corresponding power P. So please keep in the mind that for optimum arc length, the corresponding power, it is called as maximum power. And there is one shortcut for this also. I will tell you at the end of this numerical, but in the mains exam we have to write in a systematic manner. Yes, if this question is in gate examination, then you can go for direct shortcut. So first of all, for linear characteristic, we know that voltage, the circuit voltage divided by open circuit voltage plus current upon short circuit current is equal to 1. So we have the voltage relation, that is 22 plus 40L divided by open circuit voltage is 80 plus current, that is short circuit current, 100 is equal to 1. So now we have I, we have to find I in terms of L. So when you solve this, you will get I, that is a 5800 minus 4000 L divided by 80. So now we have both V and I in terms of L. So now we have the power, that is, we know the equation of power is equal to V into I. V is what? 22 plus 40L multiplied by 5800 minus 4000 L divided by 80. Okay, so when you put all these values, so you will get, when you multiply and simplify, 1595 plus 1800 L minus 2000 L square. Okay, now for maximum power, dp by dl should be 0. So differentiate with this, L 1800 minus 4000 L is equal to 0. So L is equal to, sorry, so for L you will get as a 0.45 centimeter, 0.45 centimeter, or you can say that 4.5 mm. But here unit is given in centimeter, so you have to write in centimeter. Now put this value L in this equation. So you will get power as a 2000 watt or 2 kilowatt. This is the answer, corresponding power of this arc length. So this is the answer. So if in examination like gate examination where MCQ is there, so what is the shortcut is there? When the optimum arc length and corresponding power is we have to find. So directly we can find the maximum power by open circuit voltage divided by 2 multiply by short circuit current divided by 2. Here it is 80 volt is given, divided by 2. Short circuit current, that is 100 ampere divided by 2. So solve this, you will get 2000 watt. So this is the shortcut. I hope you enjoy this session. And if you have any doubt in the previous question or this question, you can ask me in the comment section, and tomorrow we will see some new questions also.